Imagine waking up tomorrow, and every trace of the Big Bang's light had vanished. No warnings, no signs, just silence. Scientists wouldn't just lose data. They'd lose the map of reality itself, and what follows could unmake everything we think is safe. Asterisk, the universe was not born in silence. It began in fire, a blinding storm of energy so intense that for hundreds of thousands of years, light itself could not escape its prison. Photons collided endlessly with a dense ocean of particles, scattered, absorbed, and reborn in an endless cycle of chaos. The cosmos was young, hot, and furious. And then, one day, it breathed. 380,000 years after the beginning, the universe cooled enough for atoms to form. Electrons found their partners in protons, and in that embrace, light was finally freed. A first great exhalation, a moment of release. That light has never stopped traveling. It is still with us, stretched, thinned, and cooled into faint microwaves, yet saturating all of space. An invisible ocean that fills the heavens. A whisper that has lasted nearly 14 billion years. It is called the cosmic microwave. Background, the afterglow of creation. A ghostly photograph of the universe's first breath, and if it were ever to disappear, everything we know about our origins would vanish with it. For without this fragile echo, the Big Bang itself would become only a story. Asterisk, imagine a universe without stars, without galaxies, without even atoms, only a vast plasma of searing particles colliding endlessly in a violent fog. This was the cosmos in its infancy, a seething soup of electrons, protons and photons, matter and light trapped together, unable to separate. For hundreds of millennia after the Big Bang, light could not move freely. The universe itself was opaque, glowing but blind. And then, at last, the fire began to fade. As the universe expanded, it cooled. Protons and electrons slowed enough to bind together into hydrogen. This moment, called recombination, was the first great transformation of matter. With atoms now stable, photons were no longer trapped in an endless storm. They escaped. They streamed freely for the first time. The darkness of cosmic history lifted, and the first true light of the universe burst outward. This light has traveled for nearly 14 billion years. Stretched by cosmic expansion, its wavelength lengthened from searing radiation into gentle microwaves. Today, it bathes all of existence at a uniform temperature, just above absolute zero, 2.7 Kelvin. The cosmic microwave. Background, the faintest whisper of the Big Bang. Asterisk, for millennia. Humanity searched the skies, without knowing that the greatest relic of creation was everywhere. Around them, invisible, persistent, waiting in the mid-20th century. A handful of physicists dared to suggest that such a relic might exist. In 1948, George Gamow, Ralph Alptra, and Robert Herman calculated that if the universe had begun in a hot fireball, then its cooled radiation should still be detectable. They predicted a temperature of just a few Kelvin above absolute zero. The world, however, was not listening. Cosmology was still divided. The steady-state theory, an eternal universe with no beginning and no end, rivaled the Big Bang. Too many. The notion of leftover radiation from a cosmic birth was little more than speculation. The prediction of a faint afterglow was noted, then largely forgotten, a whisper in the background of science, until, by accident, it was heard. Asterisk, it was 1965. Arno Penzias and Robert Wilson, two young radio engineers at Bell Labs in New Jersey, were testing a horn-shaped antenna. Their task was not to probe the mysteries of creation, but to refine satellite communications. Yet no matter how carefully they tuned their instrument, a faint background noise persisted, a low-level hiss, constant in every direction. At first, they suspected interference. Could it be faulty electronics, urban radio, even the droppings of pigeons nesting inside the antenna? The engineers cleaned, repaired, adjusted, but the signal never vanished. The hiss was stubborn, eternal at the same time. Only miles away, a team of physicists at Princeton, led by Robert Dick, was preparing to search for the very radiation that Gamow and his colleagues had predicted decades earlier. When the two groups connected, realization struck like thunder. What Penzias and Wilson had found was no earthly noise. It was the afterglow of the universe itself, the oldest light in existence. This faint static, mistaken for pigeon droppings, became one of the most profound discoveries in the history of science. The universe had spoken, and at last humanity had heard. The nature of the whisper, the cosmic microwave background, is everywhere. It fills the night sky, invisible to the human eye, but blazing to sensitive instruments. It is astonishingly uniform, the same temperature across every corner of the cosmos. And yet, in that uniformity lies a secret. Tiny fluctuations, only 1 part in 100,000, ripple across its map. Imperceptible to ordinary sight, but visible to satellites such as COBE, WMAP, and Planck. These minute temperature differences were the seeds of everything to come. They are the fingerprints of quantum fluctuations, stretched by cosmic inflation to cosmic scales. Where the map shows a slightly warmer patch, matter was denser, destined to collapse into galaxies and stars. Where it shows a cooler patch, emptiness would reign. Every spiral galaxy, every shining star, every planet, every observer, all of it began as a faint ripple in the afterglow. The cosmic microwave background is not simply radiation. It is the oldest photograph of the universe, an image not of stars, but of the raw potential that would one day become everything. Without it, cosmology would still be blind. The Big Bang might remain only a theory, contested and incomplete. The debate between eternal universes and created ones might never have ended. But with it, the cosmos has memory. The CMB is not just a whisper. It is testimony. It is evidence that the universe was born, and that in its first fragile breath, light was released, a fossil of time itself, carried across eternity. And yet, it is fragile, for one day, in a future unimaginably distant. The expansion of the universe will stretch its wavelength beyond detection. The whisper will fade. The memory will dissolve into silence. And when it does, creation's first photograph will be lost. Asterisk. The afterglow of creation still surrounds us, a fragile whisper of fire and silence. But one day, when that whisper fades, the universe will no longer remember that it was ever born. The signal was faint, a low hum across the heavens, constant, unyielding, everywhere at once. To the untrained ear, it was nothing but static. But to those who understood, it was the universe confessing its origin. For this whisper proved what many had feared, and others had prayed for, that the cosmos had not always been here, that it had a beginning, a fiery, finite birth, and with that revelation, the foundations of science and philosophy trembled. Asterisk. For centuries, the human imagination had been torn between two visions, One was eternal, a universe without beginning or end, forever cycling, forever balanced. This was the dream of Aristotle, echoed by philosophers through the ages. A cosmos uncreated, unshaken, infinite. The other was violent, a universe born from fire, evolving, aging, perhaps even destined to die. A cosmos with history, with scars, with memory. By the mid-20th century, science itself was divided. The steady-state theory, proposed by Fred Hoyle, Hermann Bondi, and Thomas Gold, painted a picture of eternal constancy. New matter, they argued, simply popped into existence as the universe expanded, maintaining balance forever. There was no beginning, no end. Against it stood the Big Bang model, a universe born from a hot, dense singularity, expanding and cooling through time. But the evidence was fragile, incomplete. A cosmic birth was still only a controversial idea. And then the whisper arrived. The discovery of the cosmic microwave background was more than data. It was a verdict, asterisk, in 1965, when Penzias and Wilson's Horn antenna picked up the faint static. The signal was quickly compared to theoretical predictions, and the match was devastatingly precise. The radiation had a perfect black body spectrum, exactly what would be expected if the universe had once been a searing plasma. Its temperature, 2.7 Kelvin, was astonishingly close to what Gamow, Alpha, and Hermann had calculated decades earlier. This was not noise. This was prophecy fulfilled. The steady-state model crumbled almost overnight. Hoyle's eternal cosmos lost its foundation. The whisper from space left no room for doubt. The universe had once been hot, dense, and young. And with that, humanity was forced to face a terrible truth. The cosmos was not infinite in time. It had a beginning. This revelation shook even the greatest minds. Albert Einstein himself had once believed in a static universe. His equations of general relativity naturally predicted either expansion or contraction, but he resisted the idea. To preserve balance, he inserted a cosmological constant, an arbitrary term to keep the universe still. But when Edwin Hubble observed galaxies receding in 1929, Einstein abandoned the constant, calling it the greatest blunder of my life. Still, even he could not have imagined the clarity the cosmic microwave background would bring. For here, at last, was proof written in the sky. Not only was the universe expanding, it had been born in fire. The static from Bell Labs became a kind of cosmic confession, the universe admitting its violent origin. And for scientists, the implications were overwhelming. The CMB was not simply leftover radiation. It was a map, a photograph of the universe when it was only 380,000 years old, a window into the very moment when light itself was first released. It revealed not just that the universe had a beginning, but the details of that beginning, etched into every ripple of radiation. Asterisk for humanity, the revelation was not only scientific, it was existential. An eternal universe had been comforting. Infinite time meant infinite possibility. An endless cosmos meant that perhaps, in some way, we were beyond the reach of mortality, but a finite universe, one with a moment of birth. That meant it could also have an end. Suddenly, everything was fragile. Time had direction. Creation was not an endless cycle, but a singular story. The whisper of the CMB told us, the universe is mortal. It was born, it evolves, and it will die. This was more than physics. It was philosophy. It was theology. It was myth remade in data. The cosmos was no longer a stage. It was a character with an origin and a fate. Asterisk, not all accepted this easily. For many scientists, the idea of a finite birth still felt almost unscientific, uncomfortably close to ancient myths of creation. Hoyle himself used the phrase Big Bang as ridicule, mocking the concept as little more than cosmological storytelling. Yet the very name became its triumph. The evidence could not be ignored. Every telescope confirmed the same. The background radiation was everywhere, uniform, ancient dot. The whisper was too loud, too precise. In time, even those who resisted could not deny it. The universe itself was the witness. Asterisk, what began as faint static soon revealed unimaginable depths. In its near-perfect uniformity, the CMB carried subtle fluctuations, tiny variations in temperature, 1 part in 100,000, that held the seeds of all cosmic structure. These were not random. They matched the predictions of quantum fluctuations stretched by inflation. They explained why galaxies formed where they did, why matter clumped, why the cosmos looks the way it does today. The CMB was not just background noise. It was a cosmic blueprint. It told us where the great cosmic web would rise, where stars would ignite, where worlds would one day orbit suns. It was a whisper, not of what had been, but of what was to come. But pause for a moment. Imagine if the whisper had never been found. What if Penzias and Wilson had dismissed the noise? What if the Princeton team had not been listening? What if the cosmic afterglow were invisible to us entirely? Science would have remained blind. The debate over the universe's origin might still rage. Perhaps the steady-state model would dominate. Perhaps cosmology itself would be little more than speculation, starved of evidence. Without the CMB, the universe's memory would be erased. Its birth would be hidden, its origin unknowable. The whisper is fragile, and yet it carries everything. The cosmic microwave background was not just a discovery. It was a revelation. It silenced one vision of eternity and confirmed another. A cosmos with history, with evolution, with destiny. It forced science to confront beginnings and endings, to accept that the universe itself is bound by time. The whisper that Penzias and Wilson stumbled upon was more than static. It was the oldest voice in existence, and it spoke a truth humanity had long tried to deny. The universe was born. Asterisk, the whisper in the sky was faint, almost forgotten, but it shattered eternity, and in its echo we learned, even the universe itself is not forever. The whisper had been heard, but in its faintness lay a question. What secrets might be hidden in its grain, in its smallest ripples? At first, the cosmic microwave background appeared uniform, astonishingly smooth across the heavens. A near-perfect glow, the same in every direction. But science rarely accepts perfection at face value. Hidden within its silence, there had to be structure, faint scars of creation, traces of something deeper. In the 1990s, the first great attempt was launched to map it in detail. The COBE satellite, the Cosmic Background Explorer. Its instruments measured the spectrum of this ancient light with exquisite precision. What COBE found was staggering. The CMB's radiation followed a perfect black-body curve, the most precise natural spectrum ever observed in the universe. No alternative theory could explain it. The Big Bang was no longer just a model. It was fact, painted across the heavens. And then came the revelation. COBE detected minute fluctuations, anisotropies, tiny variations in temperature. So small they were only 1 part in 100,000. Yet these faint ripples were the seeds of everything. Without them, matter would never have clumped. Galaxies would never have formed, stars would never have burned, and worlds would never have been born in those ripples. The universe's destiny was written. The work continued. The Wilkinson Microwave Anisotropy Probe, WMAP, followed in 2001. For 9 years, it charted the CMB with far greater detail, mapping the faint tapestry of hot and cold spots across the sky. What emerged was a kind of blueprint, a pattern of density, a fossilized map of the early universe that explained why the cosmic web looks as it does today. And then came Planck, launched in 2009 by the European Space Agency. Its vision was sharper still. It recorded the background radiation with such precision that cosmologists could measure the age of the universe. To extraordinary accuracy, 13.82 billion years. A number written not in theory, but in light itself. The maps Planck revealed were breathtaking, a glowing afterimage of creation itself, with its delicate mottling of warm and cool. Each patch, each faint echo, the fingerprint of a quantum fluctuation stretched to cosmic scales by inflation. Here was proof that the smallest and the largest scales of existence were forever entangled. The quantum and the cosmic joined in a single canvas. Yet the closer scientists looked, the stranger the echo became. Polarization studies added further depth, revealing patterns in the orientation of light. These patterns carried hidden stories of the first stars that rayonized the cosmos, of possible whispers of primordial gravitational waves that once rippled through space-time. In its faint glow, the CMB preserved not just an image of creation, but the very tremors of its first breath. But not all was harmony, for scattered across the sky were anomalies, scars that refused to fit neatly into theory. A great cold spot, larger and stranger than models could explain. An asymmetry across hemispheres, as though the universe itself were lopsided. Alignments of fluctuations that some dared call the axis of evil, challenging the assumption that the cosmos is the same in every direction. Were these mere accidents, random statistical flukes? Or were they hints of something deeper, traces of collisions with other universes, relics of exotic cosmic textures, signs of new physics waiting to be uncovered? The whisper that once seemed uniform was now a symphony of riddles. It was not smooth. It was scarred. And in those scars lay mysteries no one had expected. The cosmic microwave background, once dismissed as faint static, had become the most powerful tool in cosmology. A map of origins, a test of theories, a challenge to everything we thought we knew. And the more we listened, the clearer one truth became. The whisper was not simple. The whisper was not quiet. The whisper of creation was stranger than anyone had imagined. The map was drawn. The echo of creation had been charted in exquisite detail. And yet, the more complete the picture became, the less it seemed to obey simplicity. At first glance, the cosmic microwave background appeared to confirm the elegance of the Big Bang and inflation. Its fluctuations matched predictions with extraordinary precision, a triumph of theory written in light. But beneath that triumph lay fractures, scars etched into the fabric of the cosmos that refused to vanish. The first was subtle but persistent, a hemispherical power asymmetry. One half of the sky seemed ever so slightly stronger in its fluctuations than the other. It was as though the universe were divided, not fully uniform, but tilted. A strange imbalance where none should exist. Then came the so-called axis of evil, a name born not of certainty, but of unease. Alignments of fluctuations pointing in suspiciously similar directions, as if the cosmos had a hidden preference for orientation. In a universe that should look the same in every direction, such alignments were unsettling, even scandalous. And then, the most haunting anomaly of all, the cold spot. A vast region in the southern hemisphere of the sky, colder than its surroundings by just enough to raise eyebrows, just enough to raise doubts. Some called it a statistical fluke, a natural outlier in a random field of fluctuations. But others suspected something deeper, perhaps the imprint of a cosmic void, or the scar of a collision with another universe, brushing against ours in the infancy of time. Each anomaly on its own might be dismissed. Together, they whispered of incompleteness. They reminded cosmologists that the CMB, for all its beauty, was not simply confirmation. It was a riddle, and riddles demand answers. The debate grew fierce. Was it noise, coincidence, or a genuine crack in the foundations of cosmology? Some argued that only chance was required, that anomalies were inevitable when one peers closely enough at randomness. But others looked to the frontiers, new physics, exotic matter, even multiverse collisions. The whisper of the CMB, once hailed as proof, now carried dissonance. And in dissonance, possibility. Inflation theory stood tall through these storms. It had explained so much: the uniformity of the cosmos, the origin of its ripples, the link between the quantum and the cosmic. But even inflation, vast and powerful, did not solve everything. The anomalies mocked its neatness, hinting that the script of creation might have additional chapters yet unseen. What if the CMB was not a settled truth, but a reminder of how incomplete our vision still is? And then came the thought experiment, unsettling, almost absurd. What if the whisper itself were to disappear? What if the cosmic microwave background was simply gone? How could such an erasure occur? The photons that make up the CMB are ancient relics of the moment the universe cooled enough for atoms to form. When light was freed from matter, they have traveled for nearly 14 billion years, stretched by cosmic expansion into microwaves. To erase them would mean tampering with history itself. Could they decay like unstable particles? Photons, as far as physics tells us, are eternal. But what if they are not? What if there exists an exotic interaction, a hidden dark sector that quietly absorbs or mutates them beyond detection? Or perhaps the disappearance would be subtler, stranger. Imagine a universe where photons are not fundamental, but emergent, a feature of deeper rules. A small change in those rules, a cosmic phase transition in the dark fabric of reality, and the CMB could vanish like a mirage. And then there is the most unnerving possibility of all. What if the CMB was never truly there? Not in the sense we believe. What if it is an artifact, a projection, a signature of simulation? If the universe were not physical in the way we imagine, but computational, then its oldest whisper could be erased by the flip of a switch, a patch in the code. The silence would not merely be observational, it would be ontological. To lose the CMB would be to lose our origin story. Cosmology would be cast into blindness. Without it, the great narrative of the Big Bang would remain conjecture, unanchored. Our map of time itself would dissolve. We would not know the age of the cosmos, its geometry, its seeds of structure. We would stumble, lost in the dark, in a universe that erases its own memory. The possibility is remote, yet its contemplation unsettles. for it reminds us how fragile our knowledge is, how dependent on this single whisper. And so, scientists continue to wrestle with the anomalies. Are they cracks in the mirror, or just tricks of reflection? Are these signs that our cosmology is incomplete, or simply the noise of chance magnified by attention? The truth remains elusive. The whisper is still there, etched across the heavens, but it is no longer a whisper of certainty. It is a voice that questions, that tempts, that dares us to look deeper in the end. The cosmic microwave background is not only evidence, it is not only a confirmation of the Big Bang, it is a riddle etched in photons, carried for billions of years, waiting for us to listen closely enough to hear what it is truly saying. And the more carefully we listen, the stranger it becomes. The whisper of the cosmic afterglow was not the end of a mystery. It was the beginning of 1,000 questions. The cosmic microwave background stood as proof that the universe had a birth, hot, violent, expanding. But its faint irregularities, its scars and patterns, demanded theories bold enough to explain their origin. And so, the greatest minds of physics turned their gaze toward the first flicker of light. Einstein's general relativity had already transformed cosmology. It showed that space and time were not static, but dynamic, that the universe itself could expand, bend, and evolve. But Einstein's equations did not predict the afterglow. They sketched the stage, not the script. The CMB belonged to a deeper story, where the rules of the very small and the very large collided. Here, quantum fields entered the tale. At scales smaller than imagination, the vacuum itself trembles. Tiny fluctuations in energy, arising from uncertainty, became magnified in the furnace of inflation. Ripples of nothingness, stretched across cosmic horizons, imprinted themselves as the faint anisotropies in the microwave sky. Those ripples became galaxies. Those whispers became the architecture of everything. Stephen Hawking carried the insight further. He revealed that black holes, once thought inescapable, were not silent prisons. They radiated, slowly evaporating over eons. If such radiation emerged from the union of gravity and quantum physics, might not the entire cosmos echo with the same principle? Hawking suggested that the birth of the universe and the whispers of the CMB were bound together, both born from quantum uncertainty, both painting fire upon the void. But the story of the CMB was not only about beginnings, it was also a ledger of what followed. Within its faint fluctuations lie the fingerprints of matter unseen. Dark matter, invisible scaffolding that shaped galaxies. Dark energy, the hidden pressure driving cosmic acceleration. Though they cannot be touched or seen, their influence is etched across the afterglow. In every subtle variation of temperature and polarization, the shadows of the invisible are written, and still the anomalies remained. The axis of evil, the cold spot, the quiet tilts in symmetry. Theories multiplied, some daring, some desperate. Some physicists whispered of the multiverse. If inflation stretched not only our universe, but countless others, then perhaps neighboring worlds brushed against ours in infancy. Such collisions could leave bruises on the microwave sky, faint imprints like fingerprints pressed into the fossil of creation. Perhaps the cold spot was one such bruise, the scar of another cosmos grazing our own. Others spoke of cosmic textures, remnants of broken symmetries in the early universe, akin to wrinkles left behind as the fabric of reality cooled and crystallized. These defects, like invisible knots in space itself, might twist the CMB in ways that mimic the observed anomalies. Domain walls, relics of primordial phase transitions, were another candidate. They would stretch across space like vast unseen membranes, dividing regions of different cosmic order. If such walls ever existed, their presence could bend the microwave sky, leaving scars in the echo of creation. And then there was the most haunting speculation: false vacuum decay. Physics suggests that the universe may not rest in the deepest state of stability, but in a fragile plateau, a false vacuum. If so, the cosmos itself is temporary. One day, perhaps tomorrow, perhaps in 1 trillion years, a bubble of true vacuum could ignite, rewriting the laws of physics as it expands at light speed. In such a scenario, the cosmic microwave background would vanish, overwritten by a new reality, erased as though it had never been. Each theory offers part of the story. Each captures a fragment of the truth, but none hold it whole. Relativity explains the shape of expansion, but not the murmur of fluctuations. Quantum fields describe the seeds of structure, but not the symmetry of anomalies. Dark energy and dark matter leave their shadow, but not their essence. Multiverse collisions tempt imagination, yet lack confirmation. False vacuum decay whispers of doom, but hides in silence. The CMB remains what it has always been: a riddle. A photograph of creation, yes, but also a puzzle whose pieces never quite align. And so the scientists return, again and again, to the frozen whisper. They scan its cold scars, trace its faint alignments, decode its polarization. They seek in it a key, not just to the past, but to the ultimate fate of reality. For if the whisper is understood, the universe itself might be understood. And if it is not, then the echo remains a haunting, a mystery that mocks even the sharpest minds. The cosmic microwave background was once celebrated as the closing argument in favor of the Big Bang. Today, it is known as something greater and stranger. It is both proof and puzzle, both map and maze. Each theory brings us closer, but none bring us home. And so the whisper waits, patient, silent, unyielding, daring us to listen more deeply. The whisper of the cosmos, once captured by chance, is now pursued with purpose. Humanity has built machines that reach for the faintest tremors in the dark, not to discover the cosmic microwave background anew, but to listen to it with sharper ears, with eyes more refined than ever before. The James Webb Space Telescope does not stare directly into the microwave afterglow. Its golden mirrors are tuned to the infrared, and yet it plays a quiet, indirect role in the same grand story. By capturing the light of the earliest galaxies, Webb measures the scaffolding that the CMB once traced. It sees the architecture built from those ancient ripples, stars born from the slight imbalances frozen into the microwave sky. Each infant galaxy Webb observes is a living echo of the CMB's first whisper, a monument raised from quantum seeds sown in darkness. But others turn their gaze directly upon the afterglow itself. Across deserts and polar plains, vast instruments scan the frozen light with increasing precision. At the bottom of the world, the South Pole Telescope cuts into the silence of the Antarctic night. In the high deserts of Chile, the Atacama Cosmology Telescope stretches its eyes to the heavens. Together, they chart the microwave sky with extraordinary clarity, resolving structures invisible to the pioneers of Bell Labs, where Penzias and Wilson heard only noise. These instruments sketch filigree patterns within patterns, subtleties etched into the fabric of creation. What they seek is more than beauty. They are listening for a signature hidden deep in the background. B-mode polarization, a subtle swirl in the orientation of light. To detect it would be to hear the voice of primordial gravitational waves, ripples in space-time itself, frozen from the instant of inflation. Such a signal would confirm that the universe once grew faster than light, ballooning from subatomic to cosmic in a fraction of a heartbeat. It would mean that gravity itself carried memory from the very beginning, etched into the CMB-like music recorded on ancient vinyl. The quest for these BMOdes has become a holy grail of cosmology. Experiments like Light BRD, a Japanese-led mission, and the upcoming CMB's 4, the most ambitious, ground-based effort ever conceived, are designed to capture the faintest tremor of those gravitational waves. They are not looking for brightness or color, but for the hidden geometry in the whisper's polarization. If found, it would be nothing less than a direct glimpse of the universe at its birth cry. And while telescopes gaze outward, particle colliders peer inward. At CERN's Large Hadron Collider, protons crash with energies mirroring the conditions of the early universe. Physicists search for signs that the standard model of particle physics, elegant yet incomplete, may be only a chapter in a larger book. They ask whether exotic particles, supersymmetric partners, or hidden forces once shaped the anisotropies of the CMB. For the afterglow is not merely a snapshot. It is a test. Every subtle variance in its spectrum challenges theories of matter and energy, forcing colliders to confirm or deny the physics written in microwave light. Here lies the frontier, to detect the faintest signatures of inflation, to discover if space itself is haunted by fields beyond imagination, to prove that the quantum foam, once dismissed as abstraction, left scars we can still read across the sky. And yet, behind this pursuit lingers a darker reflection. What if the whisper were gone? What if, one morning, the telescopes of Antarctica and Chile, the satellites in orbit, the simulations and supercomputers all reported the same silence, a universe stripped of its background song? Every theory would be broken, every model unmoored. The scaffolding of cosmology would collapse into blankness. A cosmos without its afterglow would not simply confuse, it would erase. It would leave science holding nothing but unanswered questions, staring into the greatest silence ever known. For the CMB is not just data, it is memory. It is context. It is the photograph that proves the universe has a history. Without it, the cosmos becomes an orphan, infinite, perhaps, but unknowable. And so, we keep listening, with new eyes, with sharper tools, with the quiet conviction that the whisper is still there, patient, eternal, waiting for us to learn how to hear its final secrets. The more deeply we listen, the more deeply it unsettles us. For within the quiet afterglow lies not only confirmation, but confrontation. The whisper does not fade. It grows stranger. The universe remembers. It remembers not in words, not in books, not in monuments of stone. It remembers in light. The cosmic microwave background is that memory, the faint afterglow of creation, the photograph of the moment the universe first became transparent. For nearly 14 billion years, this whisper has carried forward, crossing the gulfs of time and space, until it brushed against a radio antenna in New Jersey and revealed to humanity its own beginning. Without it, the story collapses. The Big Bang becomes conjecture, not certainty. The expanding universe turns from knowledge into speculation. If the afterglow were absent, science itself would stand in darkness, groping for origins with nothing to hold. This is more than astronomy. It is epistemology. What is knowledge without evidence? What is truth without memory? The CMB reminds us that all science rests upon fragile traces. We do not witness the birth of galaxies, we see their fossils. We do not watch the formation of atoms, we infer it from echoes. Human understanding is a house built on whispers, reconstructed from shadows left behind. Take away the CMB and cosmology loses its bedrock. The narrative of creation itself dissolves into myth, and so the afterglow becomes a metaphor, not only for the cosmos, but for us. Each human life is an echo of memory. We too are held together by traces, fading recollections, fragile testimonies, the hum of experiences carried forward. Like the CMB, memory is imperfect, stretched and redshifted by time. It grows fainter as we move away from the moments that shaped us. Yet without it, we lose ourselves. Without memory, there is no identity. Without the CMB, there is no universe we can know. The background radiation is also a lesson in entropy. Time, by its very nature, erodes clarity. Information disperses. Heat cools. Structures collapse. The CMB began as a blaze, a flood of light. Today, it is chilled to less than 3 degrees above absolute zero, stretched thin across an expanding cosmos. Tomorrow, in cosmic terms, it will slip even further. Its wavelength stretched until it no longer falls in the realm of detectable radiation. One day, no instrument, no matter how vast or precise, will be able to hear the whisper. The universe, then, is mortal in its memory. It too forgets. Imagine a far future civilization, born hundreds of billions of years from now. By then, the afterglow will have redshifted into silence. The cosmic background will be gone, swallowed by the expansion of space itself. Those future minds will gaze into the night and see only local stars and galaxies. The evidence of a beginning will be erased. For them, the Big Bang will be unknowable. The story of creation will have vanished. And so, there is a haunting symmetry. As we lose memories of childhood, of faces once beloved, of moments too fragile to preserve, so too will the cosmos lose its own childhood. What we can see now is temporary. We live in a privileged moment, balanced between the blazing birth and the final silence. We are the witnesses of the whisper, but not its eternal custodians. The CMB is more than data. It is an existential mirror. It reminds us that memory, whether cosmic or human, is fleeting, that every trace fades, that all beginnings are eventually lost to time. And so, the question grows heavier. When the last whisper of creation fades, who will remember that we once knew the universe was born? The universe began with fire, and yet it is remembered not in flames, but in whispers. The cosmic microwave background is the quietest of relics, the faint afterglow of a birth long past. For decades, it has guided science, illuminated mysteries, and anchored cosmology to evidence. It has told us we had a beginning, and that our origin was not eternal stillness, but a violent unfolding. But like all things, even this whisper is impermanent. The CMB, stretched thinner each moment by cosmic expansion, cools into obscurity. One day, its photons will be redshifted beyond detection, their voices stretched until silence reigns. When that day comes, the universe will still exist, but its memory will not. The afterglow is not eternal, and neither are we. This is the most fragile truth of all. Knowledge is not permanent. It exists only so long as memory endures, in the universe, in civilizations, in minds. The CMB proves that the cosmos has a history, but it also warns that history itself can vanish. Consider the counterfactual. What if the afterglow had never existed? What if the photons of creation had never broken free, or had been erased by unknown physics? Then our science would be blind. The universe would seem static, eternal. The story of beginnings would remain hidden, locked beyond reach. We would live inside an infinite night with no dawn. And yet, because the CMB does exist, we have known. For one fleeting span of cosmic time, humanity has stood in a privileged era, able to hear the universe's earliest memory before it fades forever. This knowledge places a weight upon us, the weight of remembrance. For if the cosmos itself forgets, then only we, for a moment, can carry the story forward. To know that all structure, all galaxies, all life, began as ripples in quantum fields, magnified by inflation, written into microwave light. To know that creation left a trace, however faint, the philosopher's question returns. What is the meaning of knowledge if it is destined to be erased? Does the fading of the CMB diminish its truth, or does it make it more precious? Perhaps it is not eternity that gives meaning, but ephemerality. The whisper is powerful precisely because it will not last. Like a last breath, it reminds us that nothing endures, not stars, not civilizations, not even the memory of the cosmos. And yet, there is beauty in this impermanence. For the universe has given us enough light to see where we came from, even if the light itself must one day dim. The afterglow has been humanity's first photograph of existence, a map of beginnings, a fragile, fading memory carried across time. The last silence is inevitable. One day, there will be no echo of the Big Bang, no trace of creation's fire. The universe will be vast, dark, and mute. Whoever or whatever remains will gaze upon an empty sky, with no evidence that there was ever a dawn. But for us, here, now, the whisper still lingers. We are the listeners, the keepers of memory, the fleeting witnesses of the universe's first light. And so, the final question lingers like a shadow across the stars when the universe forgets its birth. Who will remember that we once knew it was born?